In the second part of the lecture, we cover very quickly all the available energy sources and how they can convert into electricity. So the main energy forms are in electrical, mechanical, that means either potential, kinetic, chemical, photonic, thermal, and nuclear. So for the hydroelectric, so we use the potential energy, and then of course turn into mechanical energy through the controlling the flow rate, and that will turn the turbine, which is a mechanical process, and using the generator, it convert mechanical energy into electricity. And we use step-up transformer to step up the voltage to a few tens or hundreds kilovolt, so we can reduce the conduction loss for this transmission. We also, this slide shows you how we use coal to generate electricity. First, we pulverize the coal and then use it as a fuel to boil the water. And the water will go through 3 stages according to the temperature and pressure, and then it will turn an electric generator, and the same will convert mechanical energy into electricity. And those water will be cooled down through the cooling tower, and the water can be used for the another cycle. Nuclear power, using different materials, the action or the operating principle is the splitting of uranium atoms. That process will generate a lot of heat that can heat up the water, boil the water, and the same that will turn the turbine and a generator. So for non-conventional alternative energy, for example, wind. In Australia, there's a lot of potential for wind energies. There are different types: onshore, offshore wind turbines, different size for different power. And we, in the coming weeks, we're going to go in more detail about the design of each renewable energy sources. For example, in wind generator, we can extract a maximum power point via the mechanical part, which is the wind blade. We can turn a pitch angle in order to track the maximum power, as well as using the generator. We can track that using the different electrical operating point in order to get the maximum energy out of available wind. And also there are plenty of sunshine in Australia. It can provide a lot of power, and at present 2.4% of Australian total electricity is derived from a small scale solar power systems. Solar thermal is actually based on the heat from the sun. They use a big concave mirror, so to focus all the sun ray into a point, so that it will heat up the material, usually the molten salt, and molten salt will boil the water, and the hot water will turn the turbine, and the turbine turns to spin the electrical generator. Biomass use, we use plants, animal waste to generate electricity. We can also tap into the ocean, the tidal and wave energy. They can generate a lot of power. And as you can see this graph, and Australia have a lot of potential in wind and ocean power. So basically, we have some small scale turbine based on the tides or the wave to turn the blade, and again to generate electricity. Geothermal, we pump cold water through the pipe, and water go through the hot granite rock. So the water will heat up, and then we use the hot water to again turn the turbine and then generate electricity. So fuel cell is a different mechanism. It basically is the hydrogen and oxygen chemical reaction between this H2 and CO and O2 through the catalyst. So, and that reaction, for example, like this, so it will split the hydrogen into the hydrogen atom, ion, as well as the electrons. And the byproduct is water, so it's a clean energy. As we mentioned before, not all the renewable energies they can provide energy constantly, and at the very least, the energy is not constant. So we need to combine different energy sources together to provide steady base load for us to use. So this figure shows you how from the power generation, cogeneration through the transmission system, and we also take into a hydro to get the power through the power substation and transmission line, going to distribution line, and then through the pole transformer we get the three-phase or single-phase power. And as you can see, from the point where energy is generated and turned to electricity and through to the stage where we are using it, there are a lot of losses associated with that. So one of the advantages of using renewable energy, for example, rooftop PV or even a small wind turbine installed near the place where the electricity is consumed, is that it saves a lot of transmission loss. The second thing is that the appliances itself has to be efficient in order to make sure that the energy is not waste. So most of the electricity, according to recent statistics, is that more than half of the electricity we consume is used for space heating, cooling, cooking, etc., and also lighting. So another evidence, another study shows that without proper design or with current usage, like normal domestic usage of utility, even we turn off everything, putting them into the sleep or standby mode, we still consume around 81 watts of power per second. So there's a lot of power being consumed. So the more efficient the appliances is, it will also help to improve the energy efficiency. So this is a summary, conclusion of why we need to use renewable energies, and also how we should use renewable energy, in what way, and to improve it in a general sense. So in the coming weeks, we are going to look into the details of mechanical conversion, electrical conversion, electronics, etc.